Hey, my name is Chris Davis. I'm going to show you how to decrypt and analyze HP2 traffic in Wireshark. So the tools that we're going to be using for this is Wireshark, Chrome, and curl. Wireshark does the traffic analysis and the decryption piece, while Chrome and curl allow you to store SSL keys to be able to decrypt. The benefit of Chrome is you can interact with the website. You can use things like developer tools, which makes interacting with the website a lot easier. Curl obviously can be used to help automate command line interaction. Again, you can script things up, like maybe you had an API that was HP2 enabled and you needed to automate a task, but also store the SSL keys for debugging later. You would use curl for that. So why do we want to use these? Unfortunately, because there's not a lot of HP2 support and a lot of common tools and frameworks right now. For example, one of my favorites is Python requests. It does not have HP2 support as of the time of writing this, unfortunately. So I wanted to quickly show you, or at least give you the commands you need to build curl with HP2 and SSL support, because at least on Ubuntu 16.04, which is what I use, I found that curl did not have HP2 support built in. So I had to go through and I had to rebuild it myself. I had to remove and then rebuild it myself. So these were the commands that I had used to be able to accomplish that. It also requires curl 7.59 or greater to be able to do HP2. Also to be able to store the SSL key logs as well. So I had to build that with that support built in too. Otherwise, you can't pass the SSL key log environment variable. So going back to what I was just saying, the SSL key log file can be specified when we run our curl command, in which case we just give it the environment variable equals SSL key logs.txt, and that's just an arbitrary flat file, text file location that you want to specify. Again, and then curl and whatever curl commands and parameters you want to pass it, including the URL of the HTTP2 enabled server. Again, when you do that, it saves those SSL keys so that we can decrypt it in Wireshark later. So for the demo here, I'm going to show you how to use Chrome to actually store those SSL key logs so that we can decrypt them with Wireshark. So here, again, I'm using this on Windows, but I believe the same can be done with actually Firefox and Chromium on Linux as well. I'm not exactly sure what those command lines would be, but I'm going to use incognito, the -- SSL keylog file path. And again, I'm just specifying a flat text file on my desktop, and then I'm passing in the parameter of my local HP2 enabled web server. Before I move on, though, I wanted to show you a couple quick Wireshark filters. So Wireshark is nice in that it does have Wireshark filters built in for HP2 now, which makes things really easy, right? For example, we could do HP2.headers.method equals get. If we wanted to get just HP2, we could type in just HP2. We can specify a path. For example, if we were going to we wanted to see styles.css, we could specify the path. We could also specify a cookie. For example, maybe we were trying to debug users' login interaction. We needed to see what kind of cookies they were getting. We could specify that. Additionally, if we wanted to see just the data itself, we could do HP2 data.data, and then we could also search inside of HP2 for arbitrary values, for example, username, right? So if there's a username form field and a password form field, we could do HP2 contains and then username, and then it would Wireshark's smart enough to be able to parse through HP2 and then find that traffic for us. Let's move on to the demo. I'm going to show you how to capture traffic and then decrypt it with Wireshark and use Google Chrome to store those keys. So first thing we want to do is set a traffic capture. I'm using rawcap since by default, Wireshark is unable to sniff localhost on Windows machines. They can on Linux, but not on Windows. All right, let me close that. And then finally, we need to open up command prompt, and we need to start Chrome with the SSL keylog argument. Okay, so there's our HP2 enabled web interface running on localhost that we opened up with command prompt, and as you can see, we actually have our SSL client random keys here. So it is actually already storing it thanks to Chrome. We open up Chrome and we can inspect the traffic here on the website, and we can do a network capture. And let's just type something in, right? So at this point, maybe you're a pen tester and you're trying to analyze a web form login, right? Maybe you're trying to hack it, you're trying to figure out what's going on with it. Or maybe you're a web developer and there's an error, or you're trying to store those keys or be able to debug what's going on with the web application. So in this case, let's just say we're trying to log in. It doesn't really matter what we type in here, but let's go ahead and generate some traffic. And Chrome actually sees this as the H2 protocol, and it's able to interact with it. And so we can see that it's actually making a login request, and we can see our response even here. But that's it. That's all we needed to do. So we created some traffic. Let's go ahead and close our web server. Let's make sure our keys, yep, there's some more keys for each of those requests that we made. And then let's go ahead and close our traffic capture. And then we're going to open up our PCAP. Lever open. Okay, so the first thing we're going to notice is that all it sees is SSL traffic, right? It sees the certificate exchange, right? And it can't really do anything with it, right? It does see that it's port 4433, which is the web server that we had set up, but again, it can't evaluate as HP2 because it's all encrypted. So what we can do is Wireshark actually gives us the option to provide it an SSL keylog file, the one that we just created, in which case it can decrypt the traffic, and then we can evaluate it as HP2. So what we want to do is we want to go to Edit, and we want to go down to Preferences. And then once we open up Preferences, we want to click on the Protocols tree. And then we want to go down to SSL. Should be in here somewhere. Oh, here's SSL. Under the pre-master secret log file name, we want to open that up, and we want to specify the SSL key log file that we had created. When we do that, we can actually see immediately that some of the traffic was decrypted. So let's go ahead and go back over to our Wireshark filters that we provided earlier. Fortunately, Wireshark knows how to evaluate HP2. So HP2 is the filter we type in, and when we do that, we can automatically see all of the HP2 traffic. Now, one thing to note is you can see that the TCP stream number is the same for the entire session. The entire session is one TCP stream, and that's the performance benefit over HP 1.1, because before HP 1.1, every time it needed a resource from the server, it would have to reestablish the TCP handshake and create a new TCP stream, request the resource, get back the response, and then close the TCP stream. For example, if it was getting index.html, then that HTML would have an image in it, it would have JavaScript in it, it would have all of those things. Each and every single one of those would have to be its own separate TCP request. And we can actually see in here that it's doing the same thing, it's doing the same core concept. It's grabbing styles.css, it's making post requests to /API/login, it's grabbing some JavaScript files, but each and every single one of those is done under one TCP stream instead of many TCP streams. So just looking at here, we can actually go down to where we had done the post API login, and we can actually open up the packet here, and Wireshark has already evaluated it. It's already parsed all of the HP2 headers, and it's provided to us in a nice little graphical interface. We can actually select, just like in the other protocol analysis in Wireshark, we can actually select that value, and we can apply it as a filter, and it'll automatically apply that for us. So if we did hp2.header.value equals post, it gives us all of our post requests, which are the 5 requests that we had made previously. Additionally, HP2 has lots of filters. So if we type in HP2 and then a period, we'll actually see Wireshark will populate a bunch of filters here for us, right? Header values, flag values, data values. It's smart enough to be able to parse HTTP2 and make your life a little bit easier. So, okay, so we wanted to evaluate the post login, right? So as we can see here, HP2 has all of our header values. So we have a post, all of these things here. But again, I think what we're interested in is the username and the password form field data. And as we can see here, that's nowhere to be found. It's actually not in this packet. So let's take a look here because of the way that HP2 works. Frame number, let's start with this packet here. So 2450, so frame.number is greater than or equal to 2450. So we see here that the post request from the client is made for API/login. And then in another packet, in a data packet down further, we actually have the post parameters being sent. And so we could actually do, this is where we got that other filter here that I was specifying before, hp2 data.data. And if we type that in, we can actually see just the data requests, right? To the server and from the server data requests. Okay, so now we're interested in the username form field. So we can do hp2 data and ampersand hp2 contains. Now the contains feature says, take this protocol, I want to find only inside of these protocols, which would be hp2, I want to find this value, right? And so we're specifying username. So if we do that, we can actually see, again, just the data that has the username form field value in it. And here we can see our username and our password. And again, this would come in handy because maybe we're trying to figure out what the client-side web application is doing to the data before it's sent to the server, right? And maybe that'll help us either in a pen test, or maybe that'll help us in debugging our application. Again, another useful one that I just want to point out, I don't think is applicable to this demo, but HP headers that set the cookie, right? So we can actually parse out cookie values that way. Finally, the only thing I wanted to point out as well is when even after it's been decrypted, unfortunately, we can't just do right-click follow TCP stream, because when we do that, it just sees it as that SSL value. Unfortunately, which is just not super helpful. If it was HP 1.1 and it was HTTP without SSL, we could actually right-click and view that stream and then see it in plain text. Again, unfortunately, Wireshark does not do that, so it's not completely perfect. Finally, it will also not allow us to export HTTP2 objects, right? So when we needed that index.html or that specific JavaScript file, we can't export it through here. We can't do export objects. HP, unfortunately, just doesn't show it because it's looking for the HTTP protocol, not HTTP2.